So this is the rule for power. X to the power n, the derivative is n times x to the power n minus 1. So another example, let me just give you one more example. If you have f of x is equal to 1 over root 3, third root of x. How can I write this as a power of x? Can you tell me? If I want to write it as x to power something, what it would be?
We'll go on to the power. Let me think.
First of all, root 3
Root 3.
root 3 is x to the power 1 over 3, right?
Yeah.
But you have root 3 in the denominator. So that means the power must be
Denominator 3.
negative.
3.
Negative 1 over 3. Right? Because of this. So f 1 over root 3x is x to the power minus 1 over 3. So what is the derivative? The derivative f prime is going to be minus 1 over 3 x to the power minus 1 over 3 minus 1, which is equal to minus 1 over 3 x to the power minus 4 over 3. And you can rewrite this as equal to 1 over minus 1 over 3 times x to the power 4, then cubic root. Okay? So these are a few examples of derivative of powers. Next, I want to tell you the derivative of trigonometric function. So derivative of trig functions. So without proof, we can prove this, but it is not the purpose of this course. We accept that the derivative of sine, if you have f of x equal to sine x, and if we use that definition, the limit definition of the derivative, eventually f prime of x, we can see that it's equal to cos x. So the derivative of sine is cos. The derivative of cos x
is sin x.
Is minus sine x. So we accept as a fact that the derivative of sine function is cos and the derivative of cosine is minus sine. Okay. Now, using these two, we can, and using other rules, we can compute the derivative of tangent and so on. What rules we have so far? We have the sum, subtraction, product, and quotient rule. So let me list all the rules we have learned so far. So some rules. Of derivatives. One is derivative of the sum, like f of x plus g of x prime is f prime x plus g prime x, which is true also for minus. So fx plus minus gx prime is f prime plus or minus g prime. So this is true for both plus, adding, and subtracting. So the second is called the product rule. And by product, I mean the multiplication of two functions. And that is f of x times g of x prime is f prime x times gx plus fx times g prime x. So you can say like this: the derivative of the multiplication is equal to derivative of the first function times the second function plus the first function times the derivative of the second function. And the third rule is the quotient rule. Which is division of two functions, f of x divided by g of x prime is equal to, again, the derivative of first function times the second function minus first function times the derivative of the second divided by, now you have to divide, gx, which is the denominator, square. So derivative of f divided by g is f prime g minus fg prime divided by g squared. So these are the main rules for taking derivatives. We also call it differentiation or differentiating functions. Differentiation means taking derivatives. Okay. Something else I want to tell you, this prime symbol, you see this symbol prime, it's called prime.
F of prime, yeah.
So there are other symbols that are common that people use in textbooks, you see in math literature. And one of the other symbols that you probably see it a lot is this symbol, d by dx. This is a very good symbol in a sense that it basically says the derivative with respect to x. I mean, maybe you will see later why it is good. I don't want to go to it now, but it means basically the same thing as prime. So you have a function, but here there is an emphasis on x. That means if you have a function of x, this is basically the derivative of the function with respect to x. So, I mean, d by dx of f is basically equal to f prime of x. That's a symbol for derivative. Okay.
Makes sense.
Now let's go and see some examples of these rules. For example, the question you asked Kenny, can you read out the equation of f?
So it is
F of x is equal to It's a
Okay.
fraction, it's a quotient.
It's f of x equals 4x cubed spread 2x plus 1 over x squared.
Okay. So here we want to find, so the question is, what is f prime? So you want to find the derivative, right?
Yeah.
So here you have to use the quotient rule. Remember this rule.
Yeah.
So f divided by g prime is derivative f prime times g minus f g prime divided by g squared. So let me just write this quotient rule. So f prime of x is equal to derivative of the top. I just write the formula. This prime times, so basically the derivative of numerator times the denominator minus the derivative of denominator times numerator divided by denominator squared, right? Now, what is the derivative of 4x cubed?
4 times 3x squared.
4 times 3x squared, which is 12x
12x
squared.
squared.
Then what is derivative of minus 2x?
Minus
What is the derivative of x?
1, so 2. Negative
Minus.
2.
And the derivative of 1 is 0, right? Or maybe it's worthwhile that I use this, that I write this as a rule. I'm going to write it maybe here. Two important rules. One is the derivative of the constant function, if f of x equal to c constant, then f prime x is 0. This is one rule. Another important rule that we used here is that if you multiply some function by a number, imagine a is a number, constant number, and you want to find the derivative of a times f of x, then it is equal to a times just f prime x. So basically, when you multiply a function by a number, when you want to take derivative, you just take the derivative of the function, and then you multiply it by that number. Okay? So a times f, the whole thing prime, is equal to a times f prime. Like here, like 4 times x cubed prime is 4 times the derivative of x cubed, which is 3x squared. So you multiply 4 by 3x squared, which is going to be 12x squared. And the same thing for 2x. The derivative of 2x is 2 times the derivative of x. That is 1. So it's just 2. And the derivative of 1 constant is 0. Okay? So we computed this part. I just wrote this part, which is 12x squared minus 2. And I have to multiply this by x squared minus, now what is the derivative of x squared? Hmm?
2x.
So it's 2x times 4x cubed minus 2x plus 1 divided by x squared. Squared is x to the power 4. Right?
Yeah.
Now you just have to do the math. It's just
Four.
some manipulation, just multiplication
4
and simplification. So you have f prime on the top. You have 12x to the power 4 minus 2x squared minus 8x to the power 4 plus 4x squared minus 2x divided by x to the power 4. So f prime of x is equal to 12 minus 8 is 4, 4x to the power 4, minus 2 plus 4 is 2, 2x squared. And then you have this with this, and this with this guy. And then there is only minus 2x left on the top. At the bottom, you have x. Okay, is that clear?
Yeah.
Very good. So remember that the derivative of constant function is 0. And if you multiply a function by a constant number, the derivative of the whole thing is equal to just that constant number times the derivative of f. Okay. So some examples, more examples maybe. Imagine that f of x is equal to 2 times root x times cosine of x. Then what is f prime? Here we have to use the product rule, right? The product rule says that derivative of this product multiplication is the derivative of first function times the second function plus derivative of the second function times the first function. So f prime is equal to, what is the derivative of root x? Remember the derivative of root x. We add it here, root x.
Where is it?
The derivative of root x is 1 over 2 times root x, right?
Over.
So 1 over 2 times root x.
Times.
So here you have 1 over 2 times root x, but there is also 2 here on the top. So you multiply this by 2, then times cos x. Now what is the derivative of cos x? So here I told you that derivative of sine x is cos x, derivative
Negative
of cos x
sin x.
minus sine x. So the derivative of cos x is minus sine x times 2 times root x. Now if you simplify, for example, this part, you can, the 2 on the top and the bottom, they cancel out each other. So we get cos x over root x minus 2 times root x times sine x. Okay. Now, and let me give you another example. So you have f of x is equal to sine x over x. So f prime of x is equal to quotient rule. Derivative of sine x times x minus sine x times the derivative of x divided by x squared. Right? This is the quotient. So f prime of x is equal to, the derivative of sine is cosine.
Cos x.
So it's cos x times x minus, the derivative of x is 1. So
1.
just minus sine x over x squared. Now another important example. Tangent of x. So if f of x is equal to tangent of x. Remember, we can write tangent as sine x over cos x, right?
Yeah.
So if you want to find the derivative, then we can use quotient rule. So the derivative would be sine x prime times cos x minus sine x times cos x prime over cos x squared. So f prime would be equal to, the derivative of sine x is cos x, so it's cos x times cos x, minus the derivative of cos x is sine x minus sine x, because there is already another minus. So minus times minus is plus, so you have plus sine x times sine x over cos square. Now on the top you have cos square x plus sine square x over cos square x. What is cos square plus sine square?
1.
It is 1. So f prime would be equal to 1 over cosine square x, which is equal to secant square x, and this also equal to 1 plus tangent square x.
So we could either write it as secant to squared x or 1 plus tangent squared x.
Yeah, because 1 plus tangent square is exactly equal to secant square.
Okay. Got it.
If you, that's the grade 11 exercise. 1 plus tangent square is equal to secant square. It could be an exercise in grade 11. Trig identities. Right?
Yeah.
So 1 plus tangent square x is equal to secant square x. So an important result we have here is that if f of x equal to tangent x, then f prime x is 1 plus tangent square x, which is also equal to secant square x. So derivative of tangent is 1 plus tangent square. Derivative of tangent is 1 plus tangent. Using the same logic, can you right now compute the derivative of cotangent?
Cotangent
So remember that cotangent
is 1 over.
So f of x is equal to cotangent of x. Cotangent is inverse of tangent, which is cos x over sine x. Tangent is sine x over cos x. Cotangent is the inverse of tangent, which is cos x over sine x. Now, can you use the quotient rule? Use the quotient rule, exactly the same logic, like here, to compute the derivative of this guy. Please do it just now. So we can go over chapter 3. Let me see. 3.5. Go to chapter 3.5. And do 175. So these are exercises 3.5. $175, 177, 179, 180, 182, 183. By the way, something that I didn't mention, for example, we can also compute the derivative of secant exactly with the same. So let me do it for you now. For example, this is another example. After I finish, you do the exercise. So f of x equal to secant. So you know that secant is 1 over cos x, right? So if to find the derivative, you can use the quotient rule. So, which is basically the quotient rule says that the derivative of the top times the denominator minus the derivative of the minus 1, the numerator times the derivative of the denominator divided by denominator square. But the derivative of 1 is 0, right? So the derivative of 1 is 0. The derivative of cosine, this guy, is minus sine. So on the top, you have 0 times cos, you have 0. And then you have -1 times minus sine, so which is sine, over cos squared. And this is basically equal to sine x over cos x times 1 over cos x, which is equal to tangent x times secant x. So the derivative of secant is secant times tangent. Let me just write it.
Oh
F
my
of
God.
x equal to secant, then f prime is secant times tangent. Derivative of secant is secant times tangent. Similarly, you can do the derivative of cosecant. Now I want you to go over these questions. These are on page 285. Page 285. And that is the relation between the tangent line. So this is something new that you should learn. Please listen carefully. So I'm going to talk about tangent line. So if you have a graph of a function, imagine that we have a function y equal to, we have a function y equal to f of x, and we have the graph of this function. Let me draw the graph. For instance, something like this. Okay. So this is y equal to f of x. So the tangent line at some point, say, for example, say x equal to a, this is x equal to a. The tangent line at this point is a line that is tangent to the graph oh, sorry. It's a line like this. We say this line tangent to the graph. It means it just touched the graph very closely. It doesn't cross it. These two lines, these two curves touch each other's very closely. in the sense that I can explain it more mathematically, but intuitively, it's like they are very close to each other. And so we say that the line is tangent to the graph. So now, what is the equation of this line? The line that is tangent to the graph. So the main point, I mean, the main lesson is that the slope of the tangent line, so I'm writing it here. So the slope of tangent line at this point, at x equal to a, is equal to f prime of a. So the derivative of the function at x equal to a gives you the slope of the tangent line. So I write it as like n. Okay. So if m is the slope of the tangent line, then m is given by f prime of a. Write it here. Now, once you have the slope, then you can write down the equation of the line, right? So next step, what is the equation of the tangent line? So this is the slope. Now the equation of tangent line. So what is the equation? The equation is y minus y0 is equal to m times x minus x0. And what is x0 and y0? X0 and y0 is just one point on the line. Here, because I know that one point is just a and f of a, this point on the graph, right? The graph of the original function. Let me show it to you on this picture. So this point here is the point a and f of a. So the x coordinate is a, the y coordinate is f of a, right? So we can use a and f of a as x0 and y0. That means the equation would be y minus f of a is equal to m, which is basically equal to f prime of a times x minus x0. And this is the equation of the tangent line. So the main point is what is the slope of the tangent line? Because once you have the slope, you can easily write the equation of the line. So for writing equation of the line, what we need is just slope of the line and one point, one given point. Okay, so let me give you an example. Example is that find the equation of the tangent line to the graph of y equal to, for example, x squared times cos x minus tangent of x at x equal to 0 and x equal to another point, say pi over 4. So let's do it first at x equal to 0. In order to find the equation of the tangent line, as I said, the first and the most important thing is to find the slope. In order to find the slope, you need to find the derivative at that point. So you have to take the derivative first. Okay, so what is now the derivative? If y equal to x squared cos x minus tangent x, then y prime, or let's say f prime, this is f of x. So f prime is 2x times, I'm using the product rule, 2x times cos x minus x squared times sine x minus secant square. This is the derivative of f, right? Now, at x equal to, first I look at so first of all, when x equal to 0, then what is f prime of 0? So the slope is f prime of 0, which is equal to what? Zero times cos is 0, minus 0 times sine is 0. What is the secant square of 0?
0. Wait, secant squared of 0?
Secant is 1 over cosine.
Yeah.
What is cosine of 0?
Co 1.
1. So secant of 0 is 1. So minus secant 0 is minus 1. So the slope of the tangent line is minus 1. Also note that when x is 0, then y, what is y or f of x? F of 0, 0 times cos 0 is just 0. Tangent of 0 is 0. F of 0 is 0. Okay, so you have 1 point, which is 0, 0. And the slope is minus 1. So the equation of the line we are looking for is y equal to minus x. Right?
Yeah.
Is everything clear? If it's not, just ask me,
X
please.
equals x squared minus 10 of x at x.
Now, what if x equal to pi over 4? So that's another question. X equal to pi over 4. Let's do it for x equal to pi over 4. So if x equal to pi over 4, what would be the m, a slope? So m is the derivative f prime at pi over 4, which is equal to cosine of pi over 4 is root 2 over 2. So f prime is 2 times pi over 4 times root 2 over 2 minus x square, which is pi square over 16 times sine of pi over 4 is root 2 over 2, and secant of pi over 4 is just root 2, so secant square is just 2. So m
2 pi 4.
is this number, root 2 times pi over 4 minus pi to the power 4 times root 2 over 32 minus 2.
I have a question.
Yes.
How did you get negative pi over 16 to the power of 4?
Sorry, pi squared, not pi. Because if x equal pi over 4, x square is pi square over 16.
Oh, yeah.
Yeah,
And
it's
pi
the
squared,
power is 2, not 4, sorry.
subtract.
This is a complicated number. It's a
2 over 4.
pi over 4.
Subtract pi.
You mean this? Oh, the second line, yeah. That's, sorry, it's pi square. So this is an irrational number, but which is almost equal. Can you give me an estimate of this line number up to 2 decimals? So you can use pi equal to 3.14. Use 3.14 for pi and give an estimate for square root 2. For example, root 2 is 1.4 something, right? Just use your calculator, estimate, give an estimate of this number up to 2 decimal points.
So 2 times there's my bracket. Times pi over 4 times pi